Hello, I think we're live. Hello, everybody out there on YouTube. It's that time again. It's Lambda Lounge time. Going to get right through to it. I think we're all good. As usual, hello and welcome. Start with the general thing that we normally start with, which is come and join our Discord. For anyone who's not on the Discord and is watching on YouTube, that's the links. You can scan the QR code if you've got the app. You can follow the link in your browser if you need that. Don't worry too much about that because that'll be back at the end of the stream. So that's all good. Cool. All right. So tonight it is lightning talks. Unfortunately, Alex doing the functional TypeScript stuff, he's not been able to make it. But we've got three of our speakers. We've got Liam speaking about Rust stuff first, and then Conor on the functional JavaScript thing, and then Hakim's going to finish up with Purescript. I thought I'd keep these small and let them introduce kind of the content of the talk themselves. So yeah, that's about it really. I'm going to bring Liam in. Let's go and get Liam. Hello, Liam.
Hello.
Hello. All right. Let me. I'm going to swap to your screen, and we'll hopefully get that, and that'll be good.
Cool.
There you go. You can see behind the curtain there for a second. All right. Cool. I will leave it to you. Thank you very much. And yeah, Liam.
Hello. Yeah. So I'm Liam. I have a little lightning talk about ownership in Rust, which I guess is the main thing that people are interested in when it comes to Rust. So I guess I'll just get into it with how it works from a basic level. So this is a basic intro. This isn't anything fancy. I'm not going to be doing anything fancy. I'm just going to have some very simple examples to show you what's what. So let us get started with this image that I stole from the internet. So yeah, in order to know a little bit more about the Rust ownership system, you have to sort of just know the basics of the stack, what's a stack and what's a heap. So the stack is like a queuing data structure. So no, wait, the opposite way around. So it's last in, first out. And everything on the stack in memory is fixed sized, i.e. known at compile time. And then compare that to the heap, which is what you might think of more as what you think of when you think of RAM, just like a big lump of memory, and there's several addresses in it, and you can go to a random point in that memory, hence random access memory. These two things are important when you start looking at why Rust does what it does. So I will show you some code. So what I have on the right is just some Rust files, and what I have on the left is cargo watch. So that just watches the folder that you can see on the right, and anytime I make a change and save it, it will run. And what this is doing is just building. So everything you see in yellow are just warnings because I've made a load of examples and I'm not actually using them, and it's telling me you're not using this. Ignore them, they're fine. But later on, you will see some errors, or hopefully you'll see some errors. So let me get started. So okay, in Rust, you do not have a garbage collector. So how does that work? Well, the way it works is, say you create something. In a garbage collector language, when you stop using it, there's a program that will just check every now and then and say, okay, this isn't being used anymore. This isn't referenced anywhere. I'm going to delete it. In C++, you would delete it yourself. However, in Rust, what happens is as soon as you get to the end of a scope where a variable that you've made is, it will be dropped. And what that means is if your value is a pointer to the heap a function called drop will be called, just kind of like C++, if you're familiar with that. And that says like, free disk memory. So that is the simplest thing of how Rust is different, but then there's a lot of things around that as to, like, there's a lot of implications of doing this. So let's talk about those implications. So in Rust, each variable has an owner. Each value in Rust has a variable that's called its owner. There can only be one owner at a time, and when the owner goes out of scope, the value will be dropped. So we talked about the third point. Let's talk about each variable having one owner. So if you look at this lovely moving example, you'll see that I've got a string S1 that contains hello. It's not known at compile time, so it's stored in the heap. And then this here is, you could say pointing to S1, but it's pointing to the data that is S1. So I have two variables, S1, S2, and that looks like this. This is similar to, your C++ is sort of like having two pointers pointing to some memory address in the heap. So, it's hello, so it's got a length of 5, and it's currently got a capacity of 5. I can request more capacity from the allocator if I want, but that stuff's not important for now. So if I, in C++, if I start doing stuff, so if I want to append to a string, that's called push string. Like if I appended stuff with S2, but I also append stuff with S1, you can start to see where the problems occur. So, oh god, I'm too used to JavaScript with no semicolons. Come on, there we go. You can start to see where the problems occur, right? So I'm affecting memory. I'm affecting a value that someone else has a reference to. So what do we do? What's the way around that? In C++, the answer is be very careful. In Rust, the answer is this. So S1 basically becomes no longer valid. And you say that the value, the owner is moved to S2, and you say that just S1, you can't use it. And I don't mean that it doesn't exist. I mean, just at compile time, the type system will not let you use it. And that solves the problem of, so if we didn't do that, as soon as we got to here, and Rust mandates that you got to call the drop function on your string, you would drop twice because you have S1 and S2. But if you say, okay, S1 is no longer valid, only S2 is, and then I'll just remove that so it's not so confusing. Then when you get to here, if you just drop S2, then you've freed that memory just once. You don't have a double free error. So that is moving. So I guess I should just carry on to the next thing, which is moving in functions. So, okay, like this is interesting, but it's not anything crazy. So what happens when you use a function? Okay, so I have a function called takes ownership. And what that does is you pass it a string. And when you pass a variable to a function in Rust, that function takes the ownership, right? So what that means is I cannot use that function here, right? You see on the left, it's telling me can't borrow s as mutable as it's not declared as mutable. So I've tried to mutate it here, but the value has been moved when I did take ownership. So if I take ownership of s, then I have the responsibility to drop to free the memory of s, and that happens here. So it never goes back to here. What that looks like, I guess, in a little bit of a diagram is you have, no, that's the next bit. Wait. Okay, moving on. Referencing. you don't want to, I mean, this is kind of nice actually, because, you know, I could say do stuff with S and then return S. So that function signature would look like this. And this is starting to look like the functional stuff that we're used to, right? Like I can do stuff with S and then return it. But you don't want to keep doing that all the time. That would get quite cumbersome. If like every time you wanted to do anything with a value, you had to take ownership and give it back like that. So what you do is something called borrowing. And so you specify with functions, so this function doesn't take ownership. You have this ampersand. Ampersand is a reference, and what it says is, I'm just borrowing this, I'm not the owner. So S1 is still in scope here, and when you get to this line, that's when it's dropped. When you reach the end of this function, the S1 is not dropped. So that's what looks like this. S is a reference here to S1, which is your original pointer with all your data that lives on the heap, which is a pointer to an array in memory in, sorry, S1 is in the stack, which is a pointer to an array in memory in the heap. I hope that makes sense. So what about, this is all nice and good, and I guess we probably could leave it here since this is functional land and we love everything to be immutable. But what if you want to change some values? So that would be not my next slide. I'll just explain it here. In order to mutate something, you have to clearly state it as mutable with the mut keyword. And in order for a function to mutate something, it has to specify that its parameter is mutable as well. And in order to not become the owner of it, you can put the ampersand there for reference. And what that does is mean that I can change it. I can, add worlds to this hello string, but I'm not the owner, so it's not dropped here. It is still in scope here. So this is, I guess, similar to your not OOP, but procedural style thing, right? It kind of looks similar, except you have some compile time checks to say you can't do some funny things. So for example, so this all compiles, right? But if I did like, is this going to work if I did let S1 equals S, and then I tried to say print line. This is how you do printing in Rust. That will fail because you can't have two mutable borrows. So this is known as a mutable borrow, and this is known as a mutable borrow, and you can't have two. So that leads to this. So I can't remember who told me this, and I really should find out because I quote them all the time. But you can describe it as you can have shared state, you can have mutable state, but you can't have shared mutable state. So that's how you guarantee that nothing is mutating something that you care about that you don't have control over. And it's all done for the type system. So them's are the basics. I have no idea whether you understood them or not, but there you go. Hope it made sense. So I made a little example. Let me get rid of this stuff so that I'm got a green compiler. I made a little example of some interesting things that you can do. Like now you have this ownership system, what's the power you can do? And so something you can do is, I don't know what it's called. In my head, I call it a swallowable type. But say you're making a chess game and you have a pawn and it has a location. This is a tuple, by the way. Tuples are quite nice in Rust. It's like they yanked it straight from Haskell. So I have a struct class, whatever you used to, a type. it has a field location, which is a tuple. This is an unsigned 8-bit integer. So it has a tuple of 2 unsigned 8-bit integers, so x and y. I literally only used that so I could show you a tuple. I should have just put x and y. And I can have functions that act on this pawn struct. So I've got one, this is similar to what you've seen before. So this is a mutable borrow. You specify self when you want to work on your own data structure. So that's how you get this syntax forward one. So yeah, I can move my pawn forward. This dot one here just means the second thing in the tuple. So it's the second unsigned 8-bit integer here. So I can +1, etc., etc. Normal kind of stuff. Now, I'm not saying this is a great design, but say something externally wanted to promote this pawn to a queen. Here's my queen struct, exactly the same thing as before. If I say self, as in I'm not getting a reference from myself, I'm getting myself. What that means is nothing else can use that pawn anymore. That pawn, I mean, it doesn't disappear, like it's still there, but the compiler will not let you use that anymore. So if I use the pawn and then I try to forward 1, it says no. And it's because it says borrow with move value, but what it means is like, here's where I used the promote function. That's, I want to say swallow. It swallowed the type, right? It swallowed the pawn type. You can't use it anymore. I try to use it. It says you've used it there after it's moved. You're no longer the owner of that. You can't do anything about it, which is great for a chess game, which is a pretty dummy example. But you can also use stuff like, imagine you're trying to submit to a queue and you don't want something to be mutated after it's been sent to the queue. Well, you could say like, you could have whatever your struct is that represents your message on the queue, and you can say dot finish, take self, and no one can touch that. So like you can pretty much guarantee that if anyone gets a finished message, it will be finished and it can't be touched. An example of this that I've seen in the real lives is, where does it live? Oh, I've got it in code, I think. Yes, sorry. So this is using WebGPU RS, which is a new sort of API to deal with GPU programming. But one of the things, oh god, yeah. I mean, I don't want to explain all of this stuff because I don't even understand myself, but you have a sort of encoder and you can submit stuff to a queue, which basically, sends it to the GPU to be executed. So this finish function with this encoder ensures that no one else can mutate it. And you can prove this by, if I do a cargo build here in this project that you're seeing on the right, I've tried to keep a reference around to this thing that's being swallowed and it won't let me. But this is a cool trick. I can just drop that by putting a scope around it. There you go. So that here will mean that anything inside this scope is dropped. This is dropped, and therefore I can continue to use this thing. I guess I'm going over a bit. Sorry about that. But just a brief thing, because Jordan wanted me to show what a server would look like, what an API server would look like. There's a thing called Rocket. It's sort of the new cool thing, and it looks like this. I mean, that's the amount of code. It's sort of like your Express in Node.js or something like that. There's also, if you're looking at any sort of industry you want to get into, in Rust, they have several websites. One of them is like are we web yet? I.e., can you build API servers? Can you build single page applications in Rust? There's are we learning yet, which is do you have enough tools to build a machine learning system in Rust? And there's are we game yet, which is the same but for game development, which are all community maintained and awesome. And that's all I got. Back to you in the studio.
Yeah, absolutely. Let me pull. There we go. Cool. So if there's any questions from anyone on YouTube, I figure we'll probably do questions kind of after each talk, if there are questions, obviously. So if anyone wants to ask any questions, please ask away in the comments. We'll give it just a second. Yeah. No, thank you very much. That was really, really cool. I don't think I'd seen. I wasn't aware of the kind of the drop and how that worked. So that was quite interesting to learn about. Definitely. Have you done any of the web stuff with it, with Rust at all, or? Yeah.
No, not yet. So that thing I showed you, Rocket, which is a little framework, that's just come into the stable build. I mean, it's just been able to work on the stable build of Rust now. Before it was using the nightly build. So I sort of stayed away from it until it was a bit more stable.
that makes sense. What's John saying? I'm going to pull it up. Do any of the RWX website other than almost? Or surely Rocket, right? Surely Rocket does.
Yeah. The web one says you can. It says go.
Yeah. So there you go. Just the web one. And I mean, I don't know. Maybe there's other ones that are to tech talk ready. Definitely. Cool. I'll give it one more second. See if there's some more questions on YouTube, and then we'll grab Conor in a moment, and that'll be good. I'm really interested in Rust. I always think as well, Rust is one of those. Rust is it's very reminiscent of some of the things in Scala as well, which is obviously what I do a lot of. And it's got a bunch of things that you also find in Scala. So yeah, it's quite nice, definitely. Cool. All right, cool. I'm gonna pull Conor in. Thank you very much again, Liam. We really appreciate it. Let me grab Conor. It's Hello. Conor. Hello. Right. Thank you, Liam. I'm going to take you off for now. So, are you ready to go, Conor?
All ready? Yeah.
Yep. I'll pull that in. Yep. All right. Cool. Take it away. Cheers.
Cool. Yeah. So this month, I thought I'd talk about functional Java. So I suppose when most people hear Java, they don't usually think functional type stuff. So this is like a public service announcement, I guess. If you're doing Java and you want to be a bit more functional, you should try Vavr, because I think that's how you pronounce it, because it'll make your life nicer, hopefully. So let's dive in. I guess most people who are listening to me will probably understand why functional programming is quite nice. But in case you don't know, or you want to be convinced of it, I suppose, Java obviously is, by its nature, an object-oriented language. But that often comes with complexity you might not want generally. Using functional programming can sometimes help you express problems more simply, at least it seems that way to me. And the functional, I guess, focus on immutable values tends to bring a lot of benefits. Which they're all nice things to have. So let's go to the next slide. But obviously Java doesn't make it quite easy because Java 8 it's getting there. You've got lambdas and so on you can use. You've got a stream API. But I mean my kind of impression of Java is pretty much that it's been bolted on after the fact. It doesn't make it nice or easy for you really. It doesn't help you do a lot of functional type things. And the stream API particularly, because they made the choice to have the streams be easily parallelizable. You can't, they don't represent like a sequence of values necessarily. So you can't do stuff like folding on them. You can reduce, but it's not, it's got kind of the wrong semantics to make it easy for you. Essentially, if you just want to have a sequence of values that you want to process one at a time. So here's Vavr. So Vavr, I think, was originally called Java slang, but some lawyers got involved, so they weren't allowed to call it Java slang anymore. So It's quite nice. I was introduced to this that I'd say maybe like 3-4 months ago. I'd heard of it beforehand, but I'd not actually used it. But yeah, it's good. It's got no dependencies, so you can just import it into your project without having to worry about it kind of clashing with anything. And there's a whole bunch of nice stuff in it, like persistent collections and pattern matching and monads and all sorts of cool stuff, which make your life a bit nicer, basically. So let's have a look at some of them. This is just going to be like a kind of high-level overview, by the way. I'm not going to go into a huge amount of depth, but feel free to talk to me on Discord about it if you like. So collections. So the collection stuff is the thing that I guess they're most using, I suppose, when you use Vavr. So they have a whole series of collections. These are just the like sequential ones. They've got like sets and maps and so forth as well, of different types. So the main thing to remember, I suppose, when you're using these is that they are different to the Java ones. So it can get a little bit tricky, I suppose, if you want to mix Java collections for interop with something else and Vavr collections. So I found it's best to kind of stick to one or the other. Your mind has been very. So the list is just like a single linked list, like the kind of con cell type approach. Most things are linear in terms of the amount of time it takes to do an operation, but not kind of like getting the head. So if you just want to consume the head, this is really good. An array, it's good for like random access anywhere inside it. It'll definitely give you constant time random access. That's good. Vector is like kind of good all-rounder, and it's backed by a trie, or maybe it's tree. I'm not entirely sure how to pronounce it, but it's rare you see one of these kind of out in the wild. It's rarer than I do, so that's quite nice. But as long as your values have appropriately, rather the hash of your values of the vector are well distributed, then you can get kind of mostly constant time performance for pretty much anything you do, getting the head or tail or random access or appending things. So that's quite good. And the stream, obviously named like the Java stream, but different. It's more like it's like a lazy linked list. So you can have an infinite sequence of values. You can just use like a generation program to make an infinite sequence of integers or whatever you want to do. And these are all kind of seeks as they. So this, I think the design of Vavr was probably quite influenced by Scala, I would say. So probably a lot of the stuff, if you are familiar with Scala, you'll also be familiar with this. So the good thing about these Vavr classes, they have a whole bunch of useful methods that are really handy, like mapping, filtering, reducing, full left, full right, like and stuff that I find myself wanting when I don't have them. Like dropping a certain number of items from a sequence, or taking a certain number of items, zipping things. So let's look at an example just to show kind of how this makes your life a bit easier. I mean, this is a completely contrived example. No one would really want to do this in real life, but it's my presentation, so I can do do what I like. So this is Java 8. I want to make a list of pies, and I want to order them based on how much I like them. And conveniently, how much I like them is in alphabetical order. So I got my list. I'm going to add some pies to that list. I'm going to sort them. And then I can say, okay, well, I want to give them a numerical ranking. So I'm going to basically get the index of each of these. So the charming idiom in Java 8 to do this is you get in-stream, and then you do map to object for the values of that list. So you can see it's a bit, it's not the nicest code, let's put it that way. Because if you look at this, just if I read this, like I'm reading some text, it doesn't immediately say, oh yeah, I've got a list of pies, and I'm going to give an index to each of them, because you got this list. But then you got an entirely separate stream down here, and you can't see where my hand is pointing, but that's not the point. That is just for producing the indexes, which is not very nice. So let's look at how Vavr handles the same thing. So right off, you can see I can just make a stream of the values I want. I tell it, yeah, I want that stream sorted when it eventually computes some values. I want the index to be just popped on there, and it's got a method to do that right away, which is quite nice. Yeah, I can just do maps on the stream, and then just print out, and then you get the same map as before. Which I think this is like a nicer way of doing things. Oh, and in case you're wondering, this T is a tuple. So it's basically saying apply this function of two variables to the things in the tuple, and they happen to be an integer and the string. Yeah. So that's pretty good. And Vavr, unlike Java's kind of functional interfaces, so if you've done Java 8+, you'll know that there's not really the Java's functional interfaces, but they kind of have done it in a bit of a weird way. Like you've got kind of suppliers and consumers and stuff. But Vavr takes a more kind of perhaps straightforward approach, just as like function 0, function 1, function 2, depending on the number of arguments it has. I think up to 9. I've never actually tried to with more than 9 arguments. I'm not sure what would happen. So one for the audience, perhaps. But the Vavr functions give you lots of nice properties that you want to use with your functions, like function composition, which is pretty easy. I mean, you can do this in Java as well, but it's not nearly as simple. So, depending on the order you want to compose your functions in, you can just do function 1 and then function 2, or function 1 compose function 2, depending on which way around you want them to fire. You can lift functions. So if you've got a function that might not return a value, or might throw an exception or something, you can lift it to have, rather than having a function of A, B, and C, it's A, B, and then an option of C. You can partially apply functions, which I don't think you can do in Java, or at least not easily. You can query functions, you can memorize functions. So that's all. It's all nice. When you need this kind of stuff, it's just there for you. So that's pretty handy. And also monad. So I said the M word again. So there's lots of useful stuff that's got just like in the library. So it's got options, although it does have different semantics to Java optional, because the Vavr option is like the Scala one, I think, in that you kind of have either some value or you have none. So that means that you could have an option that has some but then null, which you can't have a Java optional that contains null. Won't let you do that. So that's something to keep in mind if you decide to use the Vavr option. You've got the try monad. So basically, this is like a faster way, I guess, of surrounding something with a try catch block and saying, "Oh, I don't care about this. Right now, I'm going to just like throw in an unchecked exception." Like if you got some library code that throws a checked exception that you just don't want to deal with, you can say, "Well, I wanted to just blow the whole thing up." In Java, you might write try and then catch the exception, just throw an unchecked exception instead. But Vavr kind of lets you do that in a nicer way. So in the try monad, you give it a runnable or a callable function. It'll run that stuff, and then it'll either let you get out the result of the thing you called, or else it'll let you get the exception out, and then you can handle it however you like. You've got lazy, so it's a bit like Kotlin's by lazy, if you know Kotlin and remember that. So it just basically does the function once and then caches it. You've got either, which probably anybody who does Scala will know what this is. But basically, it's like either a one thing or another. You kind of have a bifurcation, I suppose. And you've got feature, which, to be fair, is pretty similar to the Java feature that is in Java already, but it has like some nice kind of convenience methods around doing stuff with the feature, like mapping and so forth, which is a little bit nicer than Java's feature. Yeah. So pattern matching. So pattern matching is probably the one feature that Scala has. Everyone goes, yeah, that's really good. We should have in our language. So if you use Vavr, you can get sort of there. Not quite, I would say, because I mean, check this code out. It's not exactly the nicest code I've ever seen, I have to say, but it does work, so that's good. So if I want to match some argument, then you do so match arg of, and then you have to list out your cases like this. So case is a function, I believe. Yeah, and this dollar is also a function. And then you have a whole bunch of matches that you can use, like is in this sequence of things. And then when that case is matched, then it does this. So this run is, I think it's just a way of deferring the results rather than doing that right away. And this is the base case if you don't match anything. So it does work. I haven't used this in a lot of detail in Angular really, But it does, in my kind of testing, it does seem to work okay. I mean, if you want to do pattern matching in Java, you can use it. I don't know if you'd want to use it necessarily, because probably anybody looking at this code will think, what's going on here? So maybe a bit confusing. But yeah, that's pretty much it. So yeah, like I said, short and sweet. This is just like a try it out. It's quite good. And I even included a joke. You can make your writing Java more functional. Haha. But yeah, it is good. I think I would definitely give it like a thumbs up for me. So yeah, if you're trying to do some Java and you want to have more functional stuff, definitely try Vavr. So yeah, that's it for me. So back to you, James.
Cool. Yeah. Thank you very much. Has anyone got any questions for that on the YouTube stream at all? Once again, give it a second. I think they take a moment to come through if people do. Yeah, that pattern matching. Yeah, doesn't look. It's not exactly idiomatically Java, is it?
But I think they probably just did it so they can take off the box and say, yeah, we can do pattern matching.
Yeah.
I don't think I would probably reach that for that, like out of choice, really. So yeah.
No, I think that would, for somebody who hadn't seen Scala, they're going to look at that and go, what the hell is happening here?
Yeah.
Yeah.
Especially since like the newer versions of Java also let you do kind of switch statements that are a bit more powerful. So the number of instances where you would want to do pattern matching of that type are probably pretty low, I would say.
Yeah, definitely.
Yeah.
Slowly dwindling as Java just picks up more and more of the features from Scala and Kotlin.
Yeah. It's got multi-line strings now. You know that?
No, it's what else? Be Python next week.
I know, yeah, it's great.
Right. I don't know if we're gonna get any questions. I'll give it another 20 seconds, and then we'll grab Hakim for the final talk, which I think will be good. No, thank you very much. Thank you from the Lambda Lounge organisers to you.
Thank you. Yes, I'll thank myself.
Yeah, absolutely. All right, let's grab Hakim and let's go for the Purescript stuff. Cool. Hakim, hello.
Hello. How's it going?
I think it's going all right. Let me get your screen in as well. I'm gonna chuck you out, Conor. Sorry. All right, cool. All right, so Purescript stuff. I think I'll just leave you to get on with it, Hakim. But yeah, cool.
Brilliant. Okay, well, hi everyone. So I've been playing a lot with Purescript recently, really enjoying it. And the latest project I've got is parsing the output of git diff using Purescript. And why on earth would I be doing that, you may ask? So a while back, I got to write a Haskell video tutorial for Pact. This isn't Haskell code, this is Purescript code. But I ended up doing a very similar thing, which was typing stuff into a text editor and then, misspelling stuff, getting the wrong function name, things didn't compile, made loads of mistakes, kept on having to, refactor and make it all work. And one of the things about trying to teach somebody something by showing them code is that you want to be able to tell a story. It doesn't really matter if you misspelt data dot whatever it is I'm typing there, data dot memorize, because it's the end goal where you're getting to, not every single key press that you made going along the way. So if you think about telling a story with code, you're really thinking about your version history. And all of us with Git know how to do at least maybe squashing commits. Maybe we know a little bit about interactive rebase, add patch, that kind of thing. And people get worried about, are you kind of lying about your development history? And in a way you are. You're telling a story. And the whole point is that I think if you want to be able to show a commit history to a student, for example, and have them learn something from it, obviously you want to show them an idealized version of that. So I ended up doing this first, writing all the code, and then typing it on my screen. So I was effectively like a really slow, buggy, inefficient version of the old patch tool that takes a diff and modifies code based on it. And I did think, isn't there a better way of doing this? So I thought it'd be really interesting to see if I could parse the output of git diff and turn that automatically into a screencast. This is why I've been playing with this stuff. So First of all, I had a look at how do you actually go about doing a diff command. And here we've got two sequences of colored dots, and we want to diff those. And the basic algorithm is the longest common subsequence. And the way you figure that out is kind of by divide and conquer. So you look at each case in turn. So you start off at the beginning and you go, we've got two beige dots at the beginning. So they're obviously going to be part of the longest common subsequence. But then it gets a bit more complicated, because can you throw away that blue dot there? Well, what if that blue dot was actually part of the longest sequence? So you have to now kind of split the world into two potentials, one of which where we've thrown away that blue dot, one we've thrown away the purple dot, and then we can see what happens going on from that. And in this top version, you can see clearly that we're going to take the purple and the beige dot. And then, because we now have a nil list at the end, we can throw away the other examples. So we've got a list, a possible longest list of three, of length 3. Now, at the bottom, again, we've got two possible paths that we might want to go down. And the top one of those is very easy. We can see we've got another possible of length 3. And at the bottom, I'm not going to go into the whole detail of that, but we end up with another beige dot. So we've got a list of length 2. And if we compare the lengths of those, you can see that obviously we throw away the list of length 2, which means that we now have a tie of what's the possible longest sequence here. And you can see that in your diff results. Sometimes you get a git diff that doesn't look like how you would actually have typed it. It makes sense to the computer, but not to you. So there's a whole kind of semantic argument here. I'm going to kind of ignore that now and just take the first one of these just for the sake of argument. So how do we turn that into an actual diff? And this part's actually quite easy. We get our sequence and we line up the two sequences with this common part. And then we can easily see that the first bits that match are context. And then we have something that there was no equivalent for the second list. So it's a deletion. We've got some more context. And another bit where we've got a new thing coming in the second list. That's an addition. And that's effectively what the how a diff algorithm works. And so doing a bit of code, implementing that in Purescript is actually quite nice. And again, you're doing it by stepping through each of the cases. So in the case where either list is nil, the result's going to be a nil, so an empty list. In the case where the two sequences match at the head, then you take that match and you do the longest common subsequence of the tails. And in the case where they don't match, you're going to do two options and see which one of them is the longest. So really nice and easy. And you can see that something like Haskell or Purescript makes this kind of work really nice and easy. But there is a bit of a problem, which is that, yes, it was a divide and conquer algorithm, but we already saw that there's kind of some overlap. There's ambiguity over which of the results are going to be the best. The whole thing is NP complete. And looking it up on Wikipedia, I found out that apparently the way to get around is with dynamic programming. And we had some scary looking maths that terrified me. And then I read it a bit more carefully. And it turns out that dynamic programming means you have something that is divide and conquer, but it's NP complete. And you can kind of work around it by memoizing some of the results. So you calculate the intermediate results automatically just by adding this memorize function in there, and the whole thing would end up being adequately fast. And you'll have done git diffs, and you know it's incredibly fast for something that is an NP complete function. So I think what I learned from all of this is that implementing diff would be lots of fun, but it's not necessarily easy, because there's definitely a lot of things that I haven't considered, and the people who've written Git and other version control systems really have. So instead, I spent a lot of energy optimizing the way that I call git diff. So you can see here, I've got -u for the unified format. I've chosen a function context, and that gives me the whole of a function that's been modified, even if I only change one line in it, which is exactly what you want to see if you're demoing code to somebody. Of course, Git doesn't know anything about Purescript. It tends to be defaulting to C-like languages with their curly braces. So we have to tell git config about Purescript and tell it that the func name is a section that starts with a line that doesn't have a white space character at the beginning of it. So then I also liked using word diff, and you can see here that in this example we've deleted an S and we've added a space and a dollar space and a lowercase s, and that might be the nicest way to write things. It can be a bit weird because you end up again the computer making diff changes that as a human you'd never have done. So it may be nicer to use a word diff regular expression like this, which is any number of word characters, like letters and numbers, in a row. So that will take the whole of skip string, delete it, and add skip $string in. That may or may not give you a nice output depending on the kind of diff you're working with. So yeah. And the other thing that we'll go into a lot more detail is that last output there looks really nice for human, and it even comes with those nice colors and so on. So it's really good as a command line alias, for example, but it's not necessarily easy for a computer to parse. So if you give it the word diff porcelain setting, it gives you a slightly easier to parse output, and that's what we're going to be looking at. So I've mentioned parsing, and what is a parser in functional programming terms? We talk about parser combinators, and so here's a very simple example using one of these streams that we had before. So if we have a parser for dots, which is called beige, we can see that in this sequence it's either going to return a result, which is going to be a beige dot, and it's going to return a suffix, which is the rest of the stream after it's matched. And of course, if instead we'd had a parser called purple, which is looking for a purple dot, that would have given us an error message and a position saying, well, it failed to find a purple dot at position 0. So you've got basically a function wrapped in a new type that either returns a good result or an error result. And if you want to put these together, you might ask, how do you combine those together? And the answer, being a Haskell-like language like Purescript, is going to be monads. And so an example here would be a do notation, which skips over beige, matches as many blue or purples as it can get, skips over a beige, and then just returns the blue and purples. So you can see it's quite nice to work with, as often monads tend to be a lot easier to use than they are to explain. So this is the output that I wanted to pass. You can see that we've got a header at the top. We've got a number of hunks which have a numerical location in the file. And then you've got a list of deletions and additions that are related to that. And to parse it, you can see that I started off with a whole load of regular expressions. I haven't programmed in Perl for many years, but regular expressions are still useful for some things. And in this case, for example, matching diff and then any characters up until the new line, it's really nice and easy. And again, we can match the index, we can match dash, dash, dash. Plus, unfortunately, is a regex meta character, so we have to do that. And then, of course, even though the regex parser returns a string, that's the point of regular expressions, we don't care about that. And Purescript demands that we mark each function as being a unit type if we're not using the output of it. So there's a built-in called void, but I think skip is a bit more readable. So I create an alias called skip. So then we move on to the hunk header, and then we're going to pass the header, we're going to pass the body, and then we're going to return one of these nice record structures. I'm going to skip over the hunk header for today's talk, and then the body is this section of deletions and additions. And here you can see that we've got a new combinator, the whole idea being that we combine these different parsers, called sep end by. First of all, so the lines are insertions, deletions, or a whole run of pluses, minuses, and context. So that's in the case where we're changing part of the line, like we did with that skip string earlier. So sep end by takes a separator, which is new segment, and that's basically matching the tilde character. And so you can see we've got a run of 3 lines with a skip regex. That's going to be something we pass to this line parser, and then pure unit as well, we're going to pass to the line parser. And if all of those match, we'll get back a list of lines. So the line parser is going to then defer to another parser for segments, which I won't go into now, but that's going to pass these pluses, minuses, or a line beginning with a space, which is an unchanged thing. And you can see that we're using pattern matching. So in the case where we have a single result, which is a minus, we know that the whole line is a deletion. We've got rid of that line completely. And you can see we're using pattern matching, and we're using Purescript's nice ADT, so abstract data types, algebraic data types to return a deletion. So it's really nice to work with and really expressive. And in the above case, you can see we've got a deletion and an addition and some context. So this whole line is going to be a modify line. So I've done parsing before in untyped languages like Perl and Clojure. I'm a big fan of those languages, not knocking them. But for parsing especially, I found that working in a strongly typed language tends to be much less of a kind of a headache, and it really gives you a very powerful, very expressive way to get a good result out of it. So I now have a parser for the output of git diff. So the only problem, and this is a problem, is that the output of git diff is basically garbage. This is a nice post online about basically those nice tildes that I mentioned that were new lines. It's totally ambiguous whether they're new lines in the input or the output. And I think I could probably have worked around it, but at that point I decided to cut my losses and use Google's diff match patch algorithm instead, but that is another talk entirely. So I don't think anything's wasted, because it was a really good experience in learning how to use monadic parser combinators. Really recommend it. Purescript string parsers is not highly documented, so I would recommend looking at Haskell's Parsec, which does have some really good documentation and tutorials online, and most of the concepts are fairly easy to map onto that. And oh yes, Ostrander on words is my Haskell tutorial if you're interested in looking that up. And Finity is this work in progress project where I'm going to try and generate a automated screencast. Thanks very much. Any questions, James?
I don't know. we will see. If anyone has any questions, please put them on the chat.
Well, there was one question from Liam in the chat, which was about plumbing being more machine parsable and not porcelain, and I think Liam may be right, and that might be the reason that this output isn't very good. I think porcelain is like a sort of intermediate level. It was designed for one particular command in Git K, I think, and it worked for that, and they didn't bother doing it properly. And so yeah, I suspect if more people complained about it, we might manage to get a nice parsable output.
Yep, absolutely. I don't have any questions. I'm just seeing if any questions turn up on the YouTube chat. But other than that, I think we might be done. Let me go back over to my slides.
Thanks,
okay.
James.
Yep, thank you very much. All right, cool. We just go like this. All right, that is it for our speakers. Thank you very much again. Let me just pull up this lot. As I mentioned, if you're not on our Discord, come and join our Discord. The link is this link here. And yeah, please come along and join us. Yeah, I think that's all we've really got. We're definitely looking currently for speakers for the rest of the year as well. So if people want to speak, please do get in touch with us. We'd really like any speakers, any topics. We're definitely willing to consider. yeah, that's basically it. I think that will do it. So I'll do I have this link easily to hand? Let me see if I can post the link into. I can. Okay, there we go. It's posted in the chat. So yep, if you're not on our Discord, come and join us. Other than that, that's it. Thank you very much, everyone. And yeah, cheers.